So my name is Sir Sam, and I'm here to continue the discussion about the operation of functions. And last meeting, I've discussed to you the multiplication of functions. Now let's start discussing the division. Okay, example number 1. So if we have f of x is equal to x cubed minus 27, and g of x is equal to x squared plus 3x plus 9, let's find f over g of x. For step number 1, we will be applying the definition for dividing functions. So we will be distributing x to the f and of course to the g. So it becomes f of x over g of x. And after it, we will be substituting the given value. So f of x is equal to x cubed minus 27 over g of x is equal to x squared plus 3x plus 9. Step number 2, we will be factoring the numerator. So as you notice, our numerator is factorable while our denominator is not factorable. Okay, so since x cubed and 27 are perfect cubes, we can use the difference of cubes identity. So what is that? So that is a cubed minus b cubed is equal to quantity of a minus b times the quantity of a squared plus ab, a times b plus b squared. Okay, so we're in a is equal to x and then b is equal to 3. So that is x cubed minus 27. So x cubed minus 3 cubed. And then we will just substituting our value of a and b here. Okay, so a become x, b is 3, of course x squared, and then 3 times x is 3x, and then b squared, that is 3 squared, and that is 9. Okay, so the factor of x cubed minus 27 is x minus 3 times the quantity of x squared plus 3x plus 9. Okay, of course over x squared plus 3x plus 9. Okay, after factoring, we will be canceling the common factors and then we will be simplifying our answer. Okay, so we will be canceled out x squared plus 3x plus 9 and also x squared plus 3x plus 9 here on our numerator. So the remaining value is x minus 3. Oh, so that's over 1. So we will be writing it as x minus 3. So our final answer will be f over g of x is equal to x minus 3. So let's proceed to example number 2. So if we have f of x is equal to x cubed minus 27 and h of x is equal to 4x minus 1, let's find f over h of x. Of course, step number 1, again and again, we will be applying the definition for dividing functions, and then we will be substituting the value. So f of x will be x cubed minus 27 over h of x is equal to 4x minus 1. Okay, so since there are no common factors in the numerator and then denominator, even though if we will be factoring x cubed minus 27, there will be no value that we can cancel. So this is already the simplest form. So this is our final answer. So f over h of x is equal to x cubed minus 27 over 4x minus 1. Okay, example number 3. So if f of x is equal to x squared minus 3x minus 28 over x squared minus 8x plus 16, and g of x is equal to x squared minus 5x plus 4 over x squared minus 49, let's find the f over g of x. Okay, step number one, apply the definition for dividing functions and then substitute. Okay, so x squared minus 3x minus 28 over x squared minus 8x plus 16 divide x squared minus 5x plus 4 over x squared minus 49. Okay, step number two, we will be applying the rule in dividing rational expressions. So this part, we will take the reciprocal. Okay, so we will be reciprocal. This is a reciprocal of a fraction. So how to get it? So what we're going to do is to turn in upside down. Okay, in other words, we will swap over the numerator and denominator. So it will become like this. Okay, so x squared minus 3x minus 28 over x squared minus 8x plus 16. And from division, since we reciprocate this part, it will become multiplication. Okay? And just like what I said, we will be swapping the numerator and denominator. So x squared minus 49 will be our numerator, and x squared minus 5x plus 4 is our denominator. Then after it, we will be factoring both numerator and denominator since they are factorable. So x squared minus 3x minus 28 will be x minus 7 times x plus 4. X squared minus 8x plus 16 is x minus 4 times x minus 4. X squared minus 49, the factor is x minus 7 times x plus 7. Okay, so x squared minus 5x plus 4, the factor is x minus 4 times x minus 1. So as you can see, there is no common factor to cancel. So what we're going to do is to simplify. Okay, so as you can see on the numerator, we have 2x minus 7, so I write it x minus 7 squared. I copy x plus 4, and I copy x plus 7. While on our denominator, we have 3x minus 4, so that will become the quantity of x minus 4 raised to 3, and then just copy x minus 1. So our final answer will be f over g of x is equal to the quantity of x minus 7 squared times the quantity of x plus 7 times the quantity of x plus 4 over the quantity of x minus 4 cube times the quantity of x minus 1. Okay, example number 4. This is an example of dividing monomial to monomial. So if f of x is equal to 15x raised to 15 and g of x is equal to 3x raised to 9, let's find f over g of x. Of course, step number 1, we will still applying the definition for dividing function. Then after that is substitution. So f over g of x is equal to 15x raised to 15 over 3x raised to 9. Next step, we will be dividing. Okay, since 15 and 3, or 15 is divisible by 3, so we can cancel 15 and this 3, and this 15 become 5 because 15 divide 3 is 5. And we will be copying the variable x, and then what we're going to do to the exponent is we will be subtracting. So that is 15 minus 9. So 15 minus 9, of course, that is 6. So the final answer is f over g of x is equal to 5x raised to 6. So reminder, so if it is happen on other activity, so don't forget to subtract the exponent if you are dividing monomial to monomial. How about if we will be having a negative exponents? So if a is not equal to 0 and n is any rational number, or is a rational number, then a raised to negative n is equal to 1 over a raised to n. Example of this. So example number 5. So if f of x is equal to negative 4x raised to 5 and g of x is equal to 2x raised to 8, let's find f over g of x. So step number 1, don't forget to apply the definition for dividing functions. And then after it, we will be substituting the value, of course. So that is negative 4x raised to 5 over 2x raised to 8. And then simplify, since this is monomial dividing monomial, we cannot factor. So what we're going to do is to simplify our answer. So as you can see, negative 4 can be divided to 2. So negative 4 divide 2 is negative 2. And copy the variable x since they have the same variable. And then just like what we did on example number 1, we will be subtracting their exponents. So that is 5 minus 8. So 5 minus 8, of course, that is negative 3. And as you can see here, the exponent is negative. So this says that the negative exponent should, in the numerator, okay, so this is numerator if we're going to put over 1 here. So negative exponents in numerator get moved to the denominator and it will become positive exponent. Okay, so on another case, if the negative exponent is on your denominator, so just get it moved up to the numerator and it will become positive exponent. So if you want to have a positive exponent, all you have to do is to move it to the other part. Like if it is on numerator, the negative is on numerator, move it to the denominator, and if it is on the denominator, move it to the numerator. So on this case, the negative exponent is on numerator, so we will be moving it to the denominator to become positive exponent. So the final answer will be negative 2 over x raised to 3. So as you can see, the exponent here is already positive. So that's the example if we have a negative exponent. So thank you everyone for listening for my discussion. So that will be all for the operation of functions. Thank you.